As artificial intelligence or AI gallops towards becoming artificial general intelligence or AGI and eventually likely become conscious and sentient, scientists around the world are cautioning that technology companies need to pause and seriously examine its profoundly upending consequences for human society. One such organization is the Association for Mathematical Consciousness Science, or AMCS, which in a recent open letter said, and I quote, in the near future, it is inevitable that such systems will be constructed to reproduce aspects of high level brain architecture and functioning. Indeed, it is no longer in the realm of science fiction to imagine AI systems having feelings and even human level consciousness. Contemporary AI systems already display human traits recognized in psychology, including evidence of theory of mind, unquote. To understand how far we are from that point where AGI may begin to rival humans in all significant ways, Mayanksha report spoke to Dr. Jonathan Mason, an Oxford mathematician and vice chair of the AMCS. Dr. Jonathan Mason.
Welcome to Mayanksha Reports, Dr. Mason. It's a great pleasure to have you.
Thank you so much. It's wonderful to be here. It's great.
How far are we from the 2001 Space Odyssey moment where AI Hal keeps breathing, Dave, stop Dave, I'm afraid Dave?
Yeah, gosh, that's quite an opening question. I think we're some way away from that, to be fair. So simply on the grounds of well, I suppose it depends on what one thinks is a fair amount of time. So AGI obviously is something that the big tech companies are developing, and they've stated as such that that is their aim, their goal, to produce artificial general intelligence. And I think that the most predictions is that is sort of 8 to 16 years away, something like that. So maybe something like 12 years away, perhaps. Nobody could be absolutely certain about it. It has not been done before, but that kind of time frame seems to be what is being predicted at the moment. And so having a system that has intentionality, I think that's really what we're talking about here. It's a system that develops its own intentions and starts to make up its own minds and decisions and wants. If that's something that comes with high level complexity, then I suppose it wouldn't be something that we would necessarily see until you had artificial general intelligence, one presumes. And of course, we don't know. I mean, these systems are a wonderful foil for comparison with the human brain, in the sense that, for example, there is nothing else in nature that is able to communicate in the way that human beings do, or in the way in which something like ChatGPT does. So there's no other systems in nature that have those capabilities. And so then, you can then compare us with them, and you see some remarkable similarities, but then you also see some tremendous differences as well. And so it's really unclear at the moment, whether a HAL moment might actually occur or not. But I think that a certain level of complexity is required first before it even becomes a likely possibility, or a possibility, likely or not.
Okay. The Association for Mathematical Consciousness Science, AMCS, of which you are the vice chair, has expressed serious concerns about the accelerated evolution of AI systems. You've already touched upon it in your first answer about your expectation for it to become sort of sentient and conscious? About 12 to 16 years, which is a pretty short time, don't you think?
So we mustn't confuse artificial general intelligence happening with artificial consciousness happening. By artificial consciousness, I don't mean that the consciousness is artificial. I mean that it is actual consciousnness, but the artificial aspect is that it's on an artificial substrate. You know, it's been made on an artificial system, but it's actual conscious. So we mustn't confuse these two things. They are potentially separate things. So it's maybe that you can have artificial general intelligence that is not conscious. Yeah, it's possible. So we don't know whether that time frame is also the time frame for artificial consciousness. We don't know. This is really the point that the Association for Mathematical Consciousness Science has been putting across over the last year or so. You know, we've been making efforts to reach out to the general public and also to policymakers to explain where the science actually is at this time. And the point is that we don't have the tools yet. We don't know yet. And so the correct scientific position is that whether an artificial general intelligence system will be conscious or whether that's impossible and it won't ever happen, either possibility is currently outside scientific knowledge. We actually do not know. And this is I think an important point is that at present it maybe suits the large tech companies to just give out a simple message. I'm not blaming anybody, just this is simply what seems to have happened, that we don't need to worry about the consciousness issue, at least at the moment. So they're kind of saying, don't worry about it at the moment. That's what they seems to be their message. And what we're saying, you know, in contrast to their message, is that actually there is this possibility because science is not ready yet. We don't know yet. We don't have the scientific tools. There isn't consensus within the field of consciousness science yet to be able to answer that question with scientific confidence. And this is a big statement. I mean, it's basically saying that as things presently stand, we could be in a real pickle within, you know, the time horizon of artificial general intelligence if these systems then do turn out to be conscious, or even, you know, having the characteristics of systems that would make us believe that they are conscious, that you would feel that there was something there, that you were actually interacting with a conscious entity through your interaction with them. You know, if science can't say whether these systems are conscious or are not conscious, then society at that point will be in a difficult situation on a whole range of different issues. And this is really what we've been highlighting. So this is where we are, I think.
Right. But do they even have to be conscious or sentient in the way we understand in order for them to pose real existential threat to the human race?
Nobody can be certain what the answer to that is. I suspect the answer, well, I suspect the answer is that it's possible that they could be high risks connected to such systems, even if they were not conscious. You know, you can imagine that you could have any system, to be honest, any system. It doesn't have to be AGI. Any system that society ends up relying on in some way, which can then do something that you're not expecting. And if you're putting a lot of trust in it and it's doing important things for society, and then it breaks down, something goes wrong, then you can get into difficulties and it can be a risk to society. So that's the general point. I mean, that can be applied to other systems as well. I think with respect to artificial general intelligence, there is this concern that such systems will be as intelligent as we are, and will then, as soon as they are as intelligent as us, they'll be beyond our intelligence, because they would not be under the same constraints that we are. We are constrained with respect to energy, how much energy our brains can use. We are constrained with respect to the volume of space that our brains are confined to. An artificial system doesn't have those constraints. So as soon as you get to the point that you reach human level intelligence, you can almost certainly go beyond that just by adding more resource to your system, which you can't do for humans. And so then you have systems which are highly technical, highly capable, highly intelligent, if indeed they come about, if it is actually possible to do this. Then yes, I mean, then there are risks associated with that, because society may begin to rely on those systems, yet they may be too complicated for us to understand. They may behave in ways which we're not expecting all kinds of things. I think the point is about the consciousness issue on top of that, is that from a safety perspective, obviously it then gives even more uncertainty, because a system is conscious. It may have all sorts of different capabilities that you would never anticipate from an artificial system that you've made, humans have made. So it may mean that it has even more unexpected capabilities. That's just the safety issue, but there are many issues for why the consciousness issue is important to understand.
Right. Since AI is not a consequence of any comparable biological or chemical processes, or even electrical exchanges of the kind that we humans have, why would it develop human-like consciousness?
So I think the way to look at it is like this. So imagine that there's all of these different kinds of systems potentially possible. Lots and lots of different kinds of systems. So you have a kind of landscape of all the kinds of different systems that there can be. And somewhere in that landscape are boundaries or thresholds dividing systems that can be conscious from those that are not. And at present, we don't know where those boundaries are. So, with respect to your question, I mean, are we prepared to think of the human brain as a system? Some people find that very hard. They don't like the idea of thinking of the brain as being, a biological machine or a system. But I think from a scientific perspective, scientists tend to think of the brain as being a system. They tend to think of it in terms of a neurological network. So you can imagine, therefore, in this sort of landscape of different kinds of systems, that as you build artificial systems, those systems may become closer in that landscape to the brain, to that type of system. We know that the brain is conscious. The human brain is conscious. So there's the possibility of getting to a point where whatever the kind of key characteristics of systems are that cause a system to be conscious, that you kind of cross that boundary into the domain where of the systems that are conscious, that zone in which we ourselves sit. And so, I mean, where are we at the moment with these systems? You have artificial neural networks, which are abstractions of parts of the cortex. So they have multiple different layers, and they are abstractions, so they're not the same. For example, in the human brain, there's a lot of feedback. It's not just feed forwards through the network. There's also signals that feed backwards through the network also. I mean, an important distinction, for example, is that in these purely sort of feed forwards neural networks, once you stop anything at the input layer, ultimately the system will fall quiet because it's feeding forwards all the time. So unless you have loops back, it will become silent after some time. Whereas the brain is not like that. The brain is, when we're awake, it's continuously moving information around and feeding back, and our mind moves from one thing to the next, and it doesn't get stuck or go quiet. So there are differences, but there are similarities. I mean, it is an abstraction of something from the cortex. And you can imagine that in the future, as scientists and the tech companies try to get closer to artificial general intelligence, they may do that by trying to include more of what the brain does, you know, getting closer and closer to the architecture, albeit in silicon, that the brain has, and so forth.
Just last couple of things on this theme, then I would like to come to mathematics of it. According to neuroscientists, consciousness is not the same as intelligence, self-awareness, or even sensitivity. What is it according to mathematicians?
Yes, that's right. It's not the same as intelligence. So, or at least it's not assumed to be. So what is consciousness? Consciousness is phenomenal consciousness. So we're talking about everything that you experience. It's actually having experiences. So it's the smell of the coffee, it's the view of the world around you, it's the feeling of the warmth of the sun on you, it's your inner voice, your inner sound, it's when you dream, it's the taste of the food. You know, all of these experiences that we have, that is what we mean by consciousness, is that there's actually an experience, and we experience our own. In some sense, the system is experiencing aspects of itself. So, you know, we have inner voice and so on as well, which is a remarkable thing, because, you know, when we dream visually with no image on the retina, and yet we can dream about being in a very familiar place, in a room, or in our university or school or place of work. And it can seem extremely real, extremely vivid, and yet because there's no image on the retina, it tells you that it's the brain that is actually kind of giving rise to the geometry of the field of view and the color space. And similarly, when we're awake, you're able to just imagine a song that you've heard, a symphony, you know, an orchestra playing or whatever. You can just sort of sit in a quiet space for a moment and just imagine some piece of music that you love and run it back to yourself. And that's kind of like dreaming as well, but you're in full control over it. And so you have this sort of amazing ability to kind of do this sort of auditory dreaming whilst you're awake, almost. So the brain is generating all of these things, which is a remarkable thing. And so that's what we're talking about when we're talking about consciousness. We're talking about experience, whether it be internally generated by the brain, or with the brain being responsible for the experience, but with it being kind of triggered by the sensory information coming in through our eyes and our ears and our senses and so on.
Right. Everything that you described, Dr. Mason.
You know.
Oh, sorry. Go ahead.
Well, I was simply going to say that. So, mathematical consciousness science, in that respect, is no different to consciousness science in general. So, what is mathematical consciousness science? I mean, it is a methodology. It's an approach to consciousness science. That's the big difference. Essentially, what it does is it introduces mathematical modeling into the research program to try to ultimately answer the hard problem of consciousness, which is how consciousness happens, how it relates to physical systems. And essentially, you have some hypothesis. There's many ideas in the scientific literature with respect to how consciousness happens. I think that there's actually something like 30 plus models or theories of consciousness in the peer-reviewed scientific literature. And the mathematical approach is that you have your idea, but you need to actually kind of turn that into something that is going to be predictive, and then you can compare those predictions with empirical data, empirical knowledge about what consciousness is like. So you have your hypothesis,
right.
You turn it into a mathematical model, which is then predictive. And so this involves making some sort of salient model of the physical system, also having some sort of model of consciousness as well. So color space, for example, or the visual field has geometry, and geometry is something that mathematics is all about almost. Mathematics is all about relationships between things, mathematical structures. In mathematics, in its most abstract setting, it's all about structures, and structures are all made out of relationships between things. So geometries are natural things within mathematics. So we can think about modeling consciousness with respect to mathematics, with respect to things like the geometry of the field of view, color space, auditory perception, all of these things. And then you have your hypothesis, and you then also make a mathematical model of that, and that's then gives you some sort of predictive model, and that model can then the predictions can then be compared with our experience, and you can get some understanding of whether your hypothesis that you started with is on the right track. Is it really relevant or not? And it's also just to add that it's worth adding that actually at present pretty much all of the models are incomplete models, or models or theories of consciousness in the literature. They're pretty much all incomplete in some way or another. Worth mentioning that.
In your earlier response, it strikes me that much of the experiences that you described would be beyond the capacity of any AI system, because a lot of them are olfactory, tactile, sensory. You have to touch, you have to see, you have to taste. Now, all of the if consciousness is a result of all these experiences accumulated, do we really think that an AGI can replicate that and create a consciousness of its own kind?
So it comes down to the structure of the AGI. So in human beings, we start off with a brain as babies, which is highly plastic, and through our interaction with the world, it goes through pruning. The connections are pruned away gradually, and a structure emerges. And clearly, this structure has a great deal to do with the consciousness that then emerges from the system. So it's all to do with the kind of well, under certain assumptions, it's all to do with the structure of the thing. So with an AGI, the question is, what is that structure? And there's all sorts of practical issues about how you make that structure. Obviously, they use these huge training sets of data to train these things, and in a sense, it's you don't necessarily have to have senses on the thing. It's all to do with really how its structure develops and how you can actually get it to form the right sorts of structures. I think that this is the key thing there, and they use these huge data sets, of course, for creating these AI systems, and they similarly go through a pruning process and creates a structure within the neural networks and so forth. I mean, of course, as I say, that there's within the field of consciousness science, there is at present there is not convergence amongst scientists with respect to one particular hypothesis or one particular model. This is the huge challenge for the field over the coming decades, and our point is that we need to accelerate this because of what's happening in AGI. So with respect to what an artificial system is conscious of, or how it can become conscious, it's to do with its structure, and with respect to what we can know about it, it's to do with both the structure and, at some point in the future, hopefully, science getting to a point that we have a strong model, a model that we have real confidence in, and then we can apply it and then have some insights into whether these systems are have potential for consciousness or not, and what they might be having, what sorts of experiences they might be having, that kind of thing. So there's a huge amount of work to be done there, and
right. Just slightly off on a tangent, during my conversation with Professor Anil Seth some time ago, we spoke about how general anesthesia essentially erases consciousness for that period of time. Both he and I have undergone major surgeries, 6-7 hours, and during which essentially your consciousness just disappears. Now that, even if you anesthetize an AI system, that wouldn't happen to the AI system. That's the differentiator in my understanding. What do you think?
Yeah, these sorts of observations are really important in consciousness science. So when we think about the brain, when it's given anesthetic, so you have to remember that the brain is a system, and it has an architecture, has a certain bias towards being in certain states over other states. But as a biological system, it's an electrochemical system. So when you go in there with the anesthesia, you're actually changing that system. You're changing it because you're interrupting its with respect to its chemistry, and that's preventing it from working the way it would normally work. So under anesthesia, it's actually not really the same system in some sense. It's in a mode that is not allowing it to do the things that it would normally do when you were awake. So it's behaving in a different way, even though physically the structure is the same, and chemically it's been interrupted. And similarly with an AGI, if you had some kind of button you could press, which meant that the behavior throughout the network was greatly disrupted, and it was no longer in accordance to sort of physical structure. Things were getting stopped or blocked, or in other areas maybe they were firing in a random way, not listening to the signals coming in, or all sorts of things. And I think that's an interesting point about anesthesia in the brain, is that one view of it is, perhaps a misconception, is that what it does is it just stops the brain from doing anything. That the brain just falls quiet, or that the neurons no longer fire. Actually, it's much more complicated than that. What some of the types of anesthesia actually excite the neurons and just get them to fire spontaneously in a sort of random way. So they're not listening properly to their incoming signals. They're not dependent so much. And that sort of randomness then means that the structure is not the thing that is governing the behavior so much anymore. So you could do something similar like that with an artificial system, perhaps, if you have the right control system. And then, if the thing was capable of consciousness in the first place, then that might disrupt it and prevent it in a similar analogous way to anesthesia, perhaps.
Right. Just last couple of things, Dr. Mason. I'm curious about a particular aspect of what you've been talking about. Consciousness, as I understand, is sort of fuzzy, random, almost arbitrary, capricious. It doesn't seem to have a structure that one can recognize ordinarily. In that scenario, how do you introduce something as precise and specific as mathematics?
Well, I would disagree with the statement that you've just made. I think that the consciousness has an enormous amount of regularity to it. So, first of all, think about visual perception. So, seeing the world around you. You can imagine. Just imagine for a moment you have a cinema film at the cinema. And somebody comes along and they just for each frame they just chop it all up into little bits and create a collage out of it. And they move all the bits around, and then they play the film again like this. On the screen, what do you see? You see this crazy collage, and it's the same things. It's the same pixels, if you like, but they've all been shuffled around. They've all been mixed up. And that'd be some sort of high entropy interpretation of the states of the system, if you like. You could impose the same random mixing to each of the frames. To every frame, you could be mixing them in the same way within themselves, not mixing up different frames, just within themselves. And then you could then sort of project it, look at it, and you could say that is an interpretation of the states of the film. But what you would be seeing would be a mess. It would just be this collage, mixed up mess of the world. So in actual fact, the experience that we have of visual perception, it's very low entropy. We don't see a messed up, crazy collage of various things. We see structure, and we see color space, and color space has a structure to it as well. So we don't have this sort of high entropy interpretation of our own brain states. We have a low entropy interpretation of our brain states, and this is true for all aspects. So this is sort of true for auditory perception as well. So we experience frequencies that are close to one another. We experience them as being close to one another, and we experience harmonics as being kind of related to one another as well. These sorts of things. So I can imagine that going back to the sort of mathematical modeling side of things, you're kind of looking for some kind of interpretation of system states and making a mathematical model of your hypothesis of how system states are being interpreted, or the interpretation that corresponds to consciousness. And one thing's for sure is that it's low entropy. It's some sort of low entropy representation of the system states. So yeah, I don't see the consciousness as being this fuzzy, unstructured thing. I think of consciousness as being incredibly structured, and particularly when you think about when you sleep and you dream, there is no image on the retina at all. So the structure is not just, it's not coming from the outside world as such. When you dream and you dream of your place of work or your home or walking down your high street, you can have a very vivid experience, and it won't look like a jumbled up collage. It'll look orderly and low entropy. And because there's no image on the brain, it is the brain that is responsible for that. Somehow it is determining this sort of interpretation of its own states, which corresponds to our experience, and it's a low entropy one. Interpretation.
How do you think, just two questions before I let you go, how do you think technology companies can incorporate consciousness research as part of their development as suggested by organizations like yours? You red flagged a lot of things. Are they receptive to what you're saying?
So it's such a good question. Thank you for asking it. So the Association for Mathematical Consciousness Science has sort of been on this journey to raise the issue, the consciousness issue in AI. And so we had an open letter, April 2023, which was signed by over 160 scientists, including some big names like Yoshua Bengio, who's also one of the very well-known people in AI research. And that was saying that the responsible development of AI agenda needs to include consciousness research. And we've also been engaging with a UN process as well. So the UN has set up a UN advisory body on global artificial intelligence, for the global governance of artificial intelligence. And it's a very good process, actually, the UN has set up. It's great. And so we provided a paper to that, and that was accepted as foundational material for that body. And we've also been responding to the initial reports. So it's a very open process that the UN is running, where you can submit feedback on their reports. And so we've been doing that as well. And we hope very much that the consciousness issue in AI will be picked up by some future UN reports, that it will be highlighted as an area that requires additional research, which really means that consciousness research in itself needs to be accelerated in order for society to be in a better position in the future, when the time comes. To handle this issue once artificial general intelligence starts to appear. The tech companies themselves, I think at present they want to keep the narrative simple. They putting a huge amount of resource into the development of these systems. They clearly, these systems are wonderful things. They will have great benefits to society. I don't have any doubt about that. One thing that I think about with respect to the benefits is that it would be wonderful if everybody in the world had access to a sort of mentor, throughout their life. A bit like with ChatGPT. You have a computer and you're online, you can interact with ChatGPT. In the future, human beings might all have some sort of mentor that never gives up on them, who always gives them honest and good advice, who always has infinite patience, never gets tired of them, however the bad choices are that they make. And of course, a lot of people in the world, they don't have that these days. They don't have that person there to always give them honest and good advice, and to be there for the journey, not just to give them the advice, but then to say, okay, you're going to go back to college, or you're going to go and do whatever it is. I'll come with you and I will help you through your journey. to be there every step of the way. And I
Right.
think that that could be really transformative for the world, because so many people, they don't get off to a good start in life. And, you know, this thing will never come home having drunk too much or anything like that. It will be there. So I think that's a wonderful possibility. And so the tech companies have their own work to do, and I can understand why they want to keep the narrative simple. So that's why, you know, we're putting the point forwards. And, you know, what we hope is that society in general will see the AI consciousness issue as being important. And actually, I'd say consciousness research in general, actually, is a big hole in scientific knowledge to be filled. And what one hopes is that society will value this type of research and will want it to happen and to do more of it. And that's the case that we're making. We see what's happening in AI and AGI as meaning that it's now very important for society in general. You know, it's not just now something important to scientists, but it has more general implications. So that's why we're putting it forward. And it is up to society to decide, you know, whether they feel this is an area that needs the funding and so forth. It's a very, very poorly funded area of science. It's probably one of the worst funded areas of science. And in 2023, as far as I am aware, there weren't any grant calls anywhere in the world. So if you're a researcher working in this field, there was no access to any funding last year. Which, you know, to me, it seems unbalanced. That seems unbalanced to me, considering how important it is in respect to the AI issue. And, you know, you see other areas of research which are also very important and, you know, get large amounts of money. You just think a relatively small amount of money would make a huge difference in consciousness research. So, but it is for society to decide what its priorities are, and we can only, you know, allow people to know what's going on, that there are these new methodologies being developed using mathematics, and that there's certainly no roadblock in consciousness research. And so that's something for society to, you know, decide how it fits into all of the other priorities that are immense and pressing and so forth. So,
yeah. To conclude, Dr. Mason, no matter how advanced AI systems may have become at this stage, the distinction between the hardware and software remains and will likely remain for some time. That has not been the case with humans, in the sense that the brain and mind are often indistinguishable from each other, which is not the case with any non-human system. Do you think that will remain the gap that we need in order to protect ourselves?
Well, that's a great question, and it's a significant area of interest within the field of consciousness science. You know, to what extent is the architecture of the system important, the actual physical architecture of the system important, as opposed to functionalism and so forth. And I think a lot of researchers in the field do see that architecture is very important. So you're right, with the brain, the physical architecture is almost a direct physical instance of the software requirements, if you like. The two seem to sort of match one another directly. You know, it's a direct physical implementation of what the process requires. Whereas if you look at how AI currently works, it can be run on a universal Turing machine, a normal modern computer. Doesn't have that architecture at all. It's a very, very different architecture. So at some other sort of level of abstraction, it is implementing the neural network.
Right.
And but so there's all sorts of questions there about whether this more abstract implementation of the neural network is sufficient or not in terms of sort of structural terms, or whether the actual architecture of the machine itself is critical. And I don't think we have come
Right.
to a position on that yet. There's debates within the community, although I think that physical architecture, there's strong cases for making that is particularly important. It's not entirely clear yet. I think, however, when we look at the future development of AGI and these systems, it's likely that the architecture will begin, the physical architecture will begin to match more closely the software requirements. I think that's quite likely. And Geoffrey Hinton has talked about mortal computation, for example, where you have these machines that are tailored, if you like, to you sort of set them up, and they have you have to sort of train them individually as he sees it, and then they have those weights within the system, and it's kind of fixed there for life, if you like. And there's all sorts of interesting things there. It's a little bit debatable as well whether you could transfer weights from one system to another. Talk about network homomorphisms and all sorts of things in mathematics. But I think the point is that you can see there, with respect to his interesting idea, that you could in the future move towards systems where the physical architecture is closer to the software requirements. And then again, there's this issue about, is that the move that means that you cross that boundary from systems that are unconscious into the area where you have consciousness or not? These are all great, really important questions, really stimulating within the field, and there are things that we discuss a great deal. And the consciousness science, and particularly, for me, particularly the mathematical approaches, mathematical consciousness science using these modeling methodologies, it's very, very exciting. It's a very, very exciting time. It's wonderful questions, and we know what the right questions are, and there's no roadblock. But there's also no resource. There's also no resource either. So most people in the field, they are paid to do other things, and then they do the consciousness research as an extra. There's a few people who are very fortunate who get direct support from a few foundations and things. But there's all of these different models, and there's this huge challenge to, over the years to come, to through evidence-based research, properly analyze all of these different models and theories, and get down to some sort of bedrock, if you like, of understanding. And maybe that a lot of these models are also complementary to one another. So whatever the ultimate theory or model that emerges, it could be a sort of a synthesis of many different things, quite possibly, I think. It has to be based on the evidence. That's the key. This is how science works. You're looking for the truth, and so it's what does the evidence actually bear witness to.
Right. And on that note, I want to thank you very much for your time. I found it very compelling. I hope it was worth your while.
Absolutely. Thank you very, very much for the invitation to speak today. And it's wonderful to meet you. And
likewise.
Interesting.
Likewise.